Okay, so another example, a biologist observed the regeneration, that's regrowing, increasing of tissue cells in a burn patient. Okay, so doing some experimentation. The original skin tissue sample was 5 centimeters in diameter. The new one was about 18.5 centimeters in diameter. By what percent did the tissue increase? So again, I start with this, always. All right. So if they're talking about by what percent the tissue increased, we're talking about finding the factor and then going and figuring out the percent increase. So we must know the new and the original. The original tissue sample was 5 centimeters, so we already know that. The new one was 18.5. So we have new, we have original, and we're looking for factor. And then if we have factor, we can determine, our ultimate goal is by what we're looking for percent increase. So we've got to finish this off, not just find the factor. Okay? All right, well, let's plug in. So 18.5 is equal to 5 times F. I want to see this setup. To solve that equation, I divide both sides by F, or 5 by 5, excuse me. So, straightforward Algebra 1 question. I go over here and I pull out my calculator and I say 18.5 divided by 5 is 3.7. Let's not forget that that's a factor. Oops, let's do that in red. Okay, let me minimize that. Okay, so that's important. That's my factor. Let's be careful. The growth factor is 3.7, which is, move it 2 places to the right, is 370%. No shocker there. I would expect tissue to grow probably pretty rapidly. And remember that growth factors are 100%, which is the original, plus the percent increase. So 100% plus what gives me 370%? Well, that's 270%. And so here, in this situation, the tissue increased 270%. I don't know if that was over one day or a week or a month or whatever, but yes, it actually increased by a much larger percentage. And you can see that because going from 5 to 18.5 is a very large